Okay, this is calculations using significant figures, part one, where we're going to focus on multiplication and division. So let's start off with multiplication. And what we're going to do is we're going to take uh, three problems here. We're going to take 12.4 times 6.85, and that'll give us 84.94. We would take 25.68 times 66.5, that'll give us 1,707.72, and 89.645 times 20 gives us 1,792.9. Now, when using significant figures, what we want to do is we want to round the answer to the least number of significant digits or figures in the problem. So, let's look at these problems a little bit more closely. 12.4 has three significant figures. 6.850 has four significant figures. So what we're going to do is we're going to use the three significant figures, and we're going to, since that's the least number, we're going to express our answer to three significant figures. So 84.94 rounded to three significant figures is 84.9. We have four significant figures in 25.68. Three significant figures in 66.5. 3 is less than 4, so we're going to round our answer 1707.72 to three significant figures, and that will be 1,710 with three significant figures. We have five significant figures in 89.645, but only one significant figure in 20. So what we're going to do is we're going to take our answer 1,792.9 and round that to one significant figure. Okay, when we round that to one significant figure, what we end up with is 2,000. So we round the answer to the least number of significant figures in the problem. We're going to do the exact same thing when we do division. So for division, the same rule as multiplication applies. Round to the least number of significant figures in the problem. So we're going to do the same sort of thing. We're going to look at a few problems here, and we'll go ahead and round these to the right number of significant digits. So we got 256.89 divided by 45.67 gives us 5.62491788, and it continues on. Well, 256.89 has five significant figures. 45.67 has four significant figures. So we're going to want to round our answer to four significant figures. When you round 5.62491788, etc., to four significant figures, the answer becomes 5.625. Okay, four significant figures. Okay. So, when multiplication and division, we do the same rule. Now, in problems where we have both multiplication and division, again, the same rule is going to apply. So this is for a situation like maybe a dimension analysis problem. So if I asked how many feet are in 5.8 kilometers, what we're going to do is we're going to set up our dimension analysis where 5.8 kilometers is equivalent to, or is our starting value, given value, and we have 1 mile is 1.61 kilometers. That's a conversion factor. So the kilometers cancel, and 5,280 feet is 1 mile. And the miles cancel, and that will give us feet, and that's what the problem's asking for. How many feet are in 5.8 kilometers? So the answer to this problem, when you just multiply across the top, multiply across the bottom, do the division, as we learned when we did dimension analysis, is 1,921.11801. But we're going to use the same rule for significant figures. Okay, we're going to round to the least number of significant figures in the problems. Now, when using conversion factors, it can be a little tricky. The first number obviously has two sig figs. In the conversion factor, the 1 mile is an exact number. The measured value is 1.61 kilometers. So we're saying for exactly 1 mile, there's 1.61 kilometers. So the 1 mile is infinitely significant. The 1.61 kilometers is got 3 sig figs. Same thing with the 5,280 feet, 3 sig figs to the 1 mile's exact number. So we're going to round to 2 significant figures. When we round to 2 significant figures, we get 1,000, 19,000 feet.